Hi all, good afternoon and welcome to today's session on Introduction to Azure AI Search. So let's proceed. So before we continue with rest of the session, let's start with uh, speaker profile. So my name is Abhishek Jalan and my role is Senior Azure DevOps Engineer. I have 20 plus active Azure certifications. I have 30 plus active hyperscaler certifications. And on the screen is my LinkedIn ID. You can send me a connection request there if you want. So let's start with the background of Azure AI Search, why it is needed, and what is the problem statement here. So basically, in today's world, with the evolution of data and IT, uh, there is no lack of data. Every organization has lots of data. It is for most of the big organization, it is ranging in terabytes and petabytes. Basically, the actual problem statement is searching the relevant information from that data. For example, suppose your company is bidding for some project or some prospective RFPs for some customers, and they want uh, solution to a problem statement that has been cited by the customer. And your company might have worked on those issues earlier, but that data and that problem statement or that lesson learned information might be stored in some archive files that is stored in some of your data lakes or some other data store that you may not be aware of, or even if you are aware of the size of database might be too large to search and query, and this issue arises more when companies acquire different small companies, and the knowledge gathering the knowledge of those small companies is sometime very trouble taking to concise in a proper place and search it for a relevant information. So Azure AI Search is created by Microsoft Azure to solve all those problems. Basically, it helps you to index and process the data and information present in multiple discrete data sources, and it can index it and store that indexed information so that whenever a query is been done, it can retrieve that relevant information based on the indexes that are created. So let's start our uh, main topic today. What is Azure AI Search? So Azure AI Search is a cloud-based search engine provided by Microsoft. With this, you can use it to index and query wide range of data sources. It helps you to create a high-scale search solution. So with Azure AI Search, you can index data from large number of data sources. You can use AI and cognitive skills to enrich the index data. You can use your AI models, you can use your machine learning models on top of the various metadata provided by the documents itself. And then you can store the extracted insight into your knowledge store for analysis and integration. Pricing tier. Before we start, the pricing is the uh, main and base of any application that you start to build. So Azure Search comes into multiple pricing tier. The first of all is there's a free tier. Uh, you can use it for exploration and tutorials. Basically, if you want to learn Microsoft Azure, you can use the free tier, and I think that would be sufficient for you to experiment. And next tier is the basic tier. It is used for a small scale application, and as the name suggests, it can support maximum of 15 indexes and 2 GB of index data. So it is pretty useful if you are trying to build a particular use case uh, um, uh, for searching. For that use cases, it is pretty useful if you don't want to invest much in and your scope area is small, you can use it. Otherwise, then there is a standard which is used for enterprise scale solutions, and there are multiple subcategories under this category. So you can have S, S2, S3, S3, SD, depending on the capacity that you want for indexing and storage. Another one is the storage optimized tier basically. This particular tier is subcategorized between L1 and L2, and you can use it to create huge indexes. And trust me, huge indexes. But yes, if you are creating lots and lots of indexes, then you might have to compromise on uh, query latency because it has to travel through all the indexes and all. So yeah, you can create a large amount of indexes on the cost of higher query latency. Small concepts, replicas, and partitions. As you know, Azure AI Search supports elasticity. So basically, you can consider replicas as the instances of search service. So if you want more capacity, you can increase more replicas of Azure AI Search. Partition is used for increasing the efficiency of Azure Search. So basically, you can divide your indexes into multiple storage locations. So if you are querying a particular part of index, and you can rebuild the other part of the index. So this way, you can split your I/O operations, and your efficiency can increase. So, what are the components that make up an Azure AI search? So first of all, it is a data source. So Azure AI search support multiple data source. Few of these may be Azure Blob Storage, Azure SQL Tables, document store in Cosmos DB. So and there are many others. It is not limited to these three skill set. So as you know, for indexing purposes, if you are not using any other skills, Azure again index the data based on the metadata that is provided by the document. But you can use Azure AI skill and Azure machine learning skills to further enrich your index. So few of the example are it can detect your document languages. So basically the language in which your document is written. It can detect few key phrases from the document. It can analyze and store the sentiment score of your data of your document, and you can use your machine learning and many other custom skills. It gives you option to do that. Indexer. Indexer is the engine that drives the indexing process. So it uses the skill set, it uses the data and metadata and maps them to a particular index. Index are basically the searchable result of your indexing process. The collection of these are the collection of JSON documents with the fields containing the extracted value during the indection. Now this field you can query this field to retrieve that particular document. You can mark them these fields as searchable, sortable, filterable, various things. We'll come to them in a moment. Indexing process. So, how the indexing process works. So basically, indexing process in Azure Cognitive Search involves mapping of data from source field to an index. So how it is done? So these are the few key steps. So basically, first of all, source data is imported from various databases, various data stores, various data lakes. You may be having some documents in your sub hard drives or your on-premises storage. So it can import data from there, and then there is a enrichment step basically. So you can use various AI skills like OCR and other skills basically to perform various text analysis and various other analysis to retrieve more and more data, more processed data. Now then the third step is mapping the processed data to index fields. So this step is again of has two subcategories, implicit and explicit. So by implicit mapping, we means Azure itself determines the fields on which the output fields are mapped to the process data itself by the Azure platform. And explicit is when you define which particular field of index has to be mapped with this processed data. So that is how you map process data to search index, and then um, this output is mapped to search indexes for querying. And this is the sample how the particular index look like. So these are the few of the metadata field, like metadata is storage name, author, content, images. Okay, and these are the language and all. These are the AI skills based field, like which language a document is written. Basically, is it in German? Is it in English? So whatever it is. Now we'll go to next slide for searching an index. So by searching an index, we mean that a query can be performed on an index document to search the content that we need. So AI search support full text search. So it can pass the document with the content to find the query terms. So the syntax which it support is Lucene query syntax, and it is of two types, simple and full. And the simple syntax are called as in, okay. So it supports uh, two forms of Lucene query syntax, simple and full. Simple one is also called as intuitive syntax, and it is used for basic searches. And full is called as extended syntax for basically complex searches. So what forms a query basically? So there are few parameters uh, for a search query. So first of all is a search. It is overall called as a search expression. Query type, in which you define what type of Lucene query syntax we want to use. Is it a simple one or is it a full? Search fields. So these are the index fields that are needed to be searched. Select. So these are the fields that you want to retrieve from your query, from your search. Now, the another parameter is search mode. These are of two types, any and all. By any means, suppose you are searching, I want a comfortable hotel. So if you are searching for any, it will retrieve you all the places, all like if you, all the properties that are marked as comfortable, and all the properties that are marked as comfortable. So it will pick either of them. And if you mark search mode as all, it will pick the properties which are marked both as comfortable hotel. Let's move to other one. Search and index continued. So how it is works? So it is based on four stages. So basically, first stage is query parsing, in which your query is evaluated and reconstructed into various subqueries, and each subquery is executed separately. Second stage is lexical analysis, in which your text is converted into lowercase and stop words are removed. By stop words, we mean a and the this type of support words. So these are removed. Document retrieval. So based on your subqueries and after performing lexical analysis, document retrieval is done, in which matching documents are identified. And after that, scoring is done, in which a relevance score is assigned based on the term frequency, basically based on your searchable field and their frequency. Filters. So basically, if you are having a large data stores and you are searching something, you need to filter out, because otherwise the search will result a huge amount of information that may not be relevant. So Depending on the Lucene query syntax, you can have two types of two ways of filtering the data. The first one is a simple search expression, and the other one is when you used full Lucene syntax. So in the simple one, basically you passed filter as the part of your search criteria, as shown in the example. You are passing search criteria as London plus author is equal to reviewer. But when you are using the full Lucene syntaxes, it support complex queries, and you can pass OData filter of author equal to reviewer. So it can help. This is just an example, but in this way you can use complex filters. There is one other way to do filtering in Azure AI Search. Basically, that is the use of facets. So facets retrieve your filtering criteria based on the field values in the result sets, basically. So for using the facets, you perform an initial search uh, uh, where you marked a query against a marked field as facet. Uh, so basically, for using facet, index field has to be marked as facetable. And once you do the initial query, it will return you all the possible values of author field, and then you can use your OData filter to filter based on a particular value of the author field. Sorting. Now, basically, when you do the query, you get the result. Normally the results are based on the score, relevancy score that are assigned by Azure AI Search. But there is a way to alter it. You can use order by OData field to sort the field as per your need. So it also support ascending and descending. So you can use this expression to sort the data as per your need. Now, there is other way to enhance the index basically. So search as you type. So basically, search as you type is enhancing the search experience um, when you are starting to type your query. So first of all, first way is suggestions. So Azure AI Search can offer you suggestions based on your the query that you are typing without actually submitting that query for AI search, and it can also offer you autocomplete feature where you start typing the query and it will give you the result. It helps you in completing your query basically. Custom scoring and result boosting. So basically, this is a complex way of enhancing the index. So basically, what happens is, suppose you have a hotel database and you want to enhance the index and you want to give emphasis to few of the categories. Suppose there is a field where field of hotel type, and you want to give more emphasis on that field, and the data that it contains is like luxury, budget, premium. This type of data is present in that field, and you want to give more emphasis on this uh, on that particular field. So you can increase the relevancy of that particular field, so that if a hotel, let's say you give a high relevancy to the um, premium hotels, uh, and another, it will give more score to a document that is marked as premium category. So that way you can boost the scoring even if it doesn't have couple of features, but if it is marked as premium category, it will be shown on higher in the order in your search. And synonyms. So synonyms is the common problem with Azure AI search. So basically, suppose for example, someone wants to search about a document about United Kingdom, but United Kingdom is United Kingdom, but still people may search United Kingdom either as the whole world of United Kingdom, or maybe UK, or maybe even people can search something in Great Britain or GB. Although Great Britain and United Kingdom are different, but people can search it. So it is better to mark these words as synonyms. just to improve your search efficiency. So this marks the end of our today's session. Just a brief summary in today's session on AI search. We have learned about various components that make up a AI search engine. First of all, it is data source, skill set, index, indexer. We learned about indexing processes. We learned about how to search an index. We learned how to apply the filters. We learned how to do sorting. And we also learned how to enhance an index. And that's it for today's session. In our next session, I'm hoping we can perform some labs so that you can see these things happening in practical. This is my link to my YouTube channel and my LinkedIn profile. So if you want, you can visit me there. Thank you very much for your time. Cheers. Bye.